Robots are pretty cool. I think anyone can agree. But a lot of people don't know how they work. A robot doesn't have to be like R2D2 or Wall-E. A robot is any machine capable of performing a complex series of actions automatically, usually programmed by a computer. Today, we're going to build a robot and learn about the three main parts of any robot: motors, sensors, and a controller. So, let's build a robot that sorts Cards Against Humanity cards, black from white. Our robot has three motors: a motor that pushes cards off the top of the mixed up deck of cards, a motor that pushes cards along the track under the light sensor, and a motor that turns the cards into their final sorting bins. The second motor is the most interesting. It uses gears to split the motion between three different sets of wheels, because some gears are spinning multiple other gears. Gears also have different sizes based on the number of teeth. When a big gear is attached to a motor, it will go slower than a smaller gear attached to the same motor. This is because the big gear has a larger circumference, so one rotation takes longer to complete. This allows for a single motor to run multiple tasks at different speeds, through gearing up or gearing down. The second thing in every robot is sensors. In our robot, we use a light sensor, which shines a red light on the cards and detects how much light is reflected back. As you may know, black things absorb light and white things reflect light. So we get a low reading when black cards go under the light sensor and a high reading when white cards go under the sensor. The light sensor is like the eyes of the robot, because sensors allow robots to see the world like human senses. When I see something, it's my brain interpreting the data that my eyes are transmitting. Now, the robot can't do anything with the information from the light sensor without the controller, just like I wouldn't be able to see if all I had were eyes and no brain. The controller holds the programs and tells the motors and sensors what to do and when to do it. The motor doesn't know what the sensor is doing, it just does what it's told. But the controller knows what each piece is supposed to be doing. It's like the manager in an office. The controller receives the data from the light sensor and tells the motor that runs the sorter which way to turn so that the cards end up in the right place. A controller needs programs, and while programs aren't technically a part of the physical robot, it's important to understand what they do. A robot is like a construction worker that has never seen a house before, trying to build a house. It needs a plan to follow. Our program tells it to move the first two motors until the card is underneath the light sensor. Then it has a switch, which tells the third motor to move one way or the other, depending on the amount of light detected. One of the most important things to understand about robots isn't how to make them or how to program them, is that sometimes they just don't work. I referee Lego robotics competitions with my dad, and one of the things we see all the time are kids that miscalculate one little thing, and the robot just doesn't quite work. What my dad tells them every time is, "You still built a robot. That's awesome!" Building robots is super cool, and the best engineers can take failures and use them to build an even better robot.